In general, a polynomial can have any degree, n, right, where n is a natural number. So a polynomial function, if we're going to call it p of x, of degree n, could be written in the form an x to the n plus an minus 1 x to the n minus 1 plus blah blah blah, and eventually you get down to a1x plus a0. So this, the an x to the n, is what you would call the leading term, because it's the highest power term, right? N is the highest power. And then down there, the a0 is what you would call the constant term. And the only requirement here with these a's, an minus 1, blah blah blah, a1, a0, is that a sub n cannot be equal to 0. And the reason being is if a sub n was equal to 0, then this would no longer be a polynomial of degree n, it would be degree n minus 1, right? So the only requirement on those coefficients there is that a sub n cannot equal 0. And a sub n actually has a name too, since an x to the n is the leading term. A sub n is known as the lead coefficient. Alright? So what they ask you in number 8 then is write a possible equation for a 5-term polynomial that has the following long-run behavior. Alright, so the long-run behavior is as x goes to negative infinity, y goes to infinity, and as x goes to infinity, y goes to infinity. So that long-run behavior means that this polynomial has even degree and a positive lead coefficient. Because what does it do? It goes up to the right and to the left. So any polynomial that goes up to the right and to the left, right? The idea is this. Say this is your axes, right? You don't know what happens in the middle. In the middle, it could go up and down a bunch of times. But you do know that all the way to the left, it's going up, then it does a bunch of stuff in the middle, and then all the way to the right, it goes up. So whenever you have a polynomial that looks like that, it's going to have an even degree and a positive lead coefficient. And in this case, it has to be 5 terms. So I could make it a 4th degree, or a 6th degree, or an 8th degree, or a 10th degree, as long as it has 5 terms and the lead coefficient is positive. So the simplest thing to do is just to make it a 4th degree with a positive lead coefficient. So I mean, the most simple thing to do is just make all the coefficients 1. So I can just say it's x to the 4th plus x cubed plus x squared plus x plus 1. It's not very interesting, but yes, it does have 1, 2, 3, 4, 5 terms. It has an even degree, right? 4th degree, and it has a positive lead coefficient because the lead coefficient is 1, right? So now in number 9, we actually have an example of a polynomial. So this one happens to be negative 2x cubed plus 20x squared minus 50x. And why did I highlight negative 2x cubed? Because that leading term gives me the degree and the lead coefficient. So this one has an odd degree because that's a 3 there, right, which is odd. And it has a negative lead coefficient. So what does this look like? If it has an odd degree and a negative lead coefficient, like that. And again, I put all those squiggle lines in the middle there because we don't know what it does here. What it does in the middle, we don't know. But what we do know is that to the left it goes up and to the right it goes down. So if it goes up to the left and down to the right, that means that as x goes to negative infinity, right, that's to the left, what does it do? It goes up to infinity, And as it goes to the right, as x goes to infinity, what does y do? It goes down to negative infinity. So that's the long run behavior, right? So whenever they ask you for long run behavior, you immediately write these two statements down. As x goes to negative infinity, and as x goes to positive infinity. That's what long run behavior means. What happens as x goes to the left, and what happens as x goes to the right. And then you just fill in what it does. In this case, it goes up to the left, down to the right. So part B says find the zeros algebraically. Zeros are another name for x-intercepts. So I'm setting y, or f of x, equal to 0. And solving. So I can factor out a negative 2 here, actually a negative 2x, and then I'd be left with x squared minus 10x plus 25. And now this is going to factor more. It factors into x minus 5 times x minus 5. So what are my intercepts? I actually only have two intercepts. This is going to give me x equals 0, and both of these are going to give me x equals 5. So my zeros are 0 and 5. But what's going to happen is, since the x equals 5 occurred twice, it's going to have what we call even multiplicity. And what's going to happen there is it's going to bounce. And I'll show you this when we write the graph. Right? So they say write this in factored form and use a sign diagram to determine the intervals where the graph is above the x-axis and below the x-axis. So what you have to do here is write it in factored form, so we know it's negative 2x times x minus 5. I can write it as x minus 5 squared. That's going to help me in this case. And what it means to write a sign diagram is you put a little number line here and you write down the numbers that are zeros, which are 0 and 5. And then what I'm going to do is I'm going to test points in each of these three intervals that I've created here, right? I have an interval from negative infinity to 0, an interval from 0 to 5, and an interval from 5 to infinity. And I'm going to check whether the function is positive or negative at these three values. So if I plug in a negative 1 for x, right, I would have negative 2 times negative 1, which is going to be a positive, and then I would have x minus 5 squared. But the fact is, anything squared is going to be positive. So this is going to be a positive times a positive over here. So over here, it's going to be positive. So from negative infinity to 0, it's going to be positive. Now at 1, what happens? At 1, if I plug in 1 for x, I have a negative 2, which is negative. And we said before, put that in parentheses, it makes it easier. Anything squared is going to be positive. So in this interval here, I have a negative times a positive, which is going to be negative. And then at 6, I'm going to have a negative 2 times 6, which is going to be a negative 12. So a negative times anything squared is going to be positive. Therefore, over here, it's going to be negative again. So bottom line is, where is f of x positive? Or above the x-axis, as they're putting it. It's positive from negative infinity to 0. And where is it negative? Where is it below the x-axis? From 0 to 5, and then again from 5 to infinity. Right? You put that little union sign there between them because it's going to be positive in both those cases. So what does that now mean? That means that at 5, it doesn't actually cross the x-axis. It just touches and bounces off. And that's the whole idea of even multiplicity. If a 0 has even multiplicity, it's going to mean that the graph is going to bounce at that point, in this case, which x equals 5, right? So what I can do now is I can sketch the graph. I know that I have a 0 at 0, and I have a 0 at 5. And what did we just say? We just said that from negative infinity to 0, it's positive, and then from 0 to 5, and then from 5 to infinity, it's negative. So it's going to look something like this. Whoa. Sorry about that. So bottom line is, it goes up to the left, down to the right, which we said at the very beginning, right? As x goes to negative infinity, y goes to infinity, so that means it goes up to the left, and as x goes to infinity, y goes to negative infinity, down to the right. And then we used our sign diagram to tell where it was positive and negative. So it just bounces there at x equals 5. It's supposed to be a smooth curve, right? Any polynomial is a smooth curve. And there's my zeros. Now you might ask yourself, what is that point there? You know it has to turn somewhere there, but you just don't know where it is. And yeah, at this point we don't know. That question mark will be answered in calculus. And then 10, write down the correct function corresponding to the graph. So this is kind of the reverse of what we just did in 9, right? In 9, we actually were given the equation and wrote and then graphed it. Here we're given the graph, and now we're going to have to write the equation. So bottom line here is, with this is, any polynomial you're going to be able to write as this form. Some constant, c or a, whatever you want to call it, and then times x minus r1, x minus r2, dot dot dot, to x minus rn, right? And what are the r's? The r's are the zeros. So in this case, you have zeros at negative 1, 1, and 2. So you know that this function is going to be c. We don't know yet what the constant is, but then x minus negative 1, which is x plus 1, times x minus 1, times x minus 2. And how did we know that they're just raised to the first power? Because none of them bounced, right? If they bounced, then it would go back to what we did in the last problem, where it would have an even multiplicity, and we'd have to put the factor as being squared. But in this case, they're not bouncing off those numbers, right? They're just crossing there. Therefore, they're just going to be the first power. So now the only thing left to do is find the value of c, and the way that I can find the value of c is by using the y-intercept. I know that when x equals 0, y is 4. So in other words, p of 0 equals 4. So I can solve this equation. 4 equals c times 0 plus 1 times 0 minus 1 times 0 minus 2. So what is this? C times 1 times negative 1 times negative 2. So it's really just 4 equals negative 2 times negative 1 times 1 is 2. 4 equals 2c. So c is going to really equal 2. So there's my function.